Hi, welcome to my video on the existence of a limit number 2. I decided to do a second video because I wanted to do some questions that are similar but yet different. The existence of a limit. Number 1, the f of x equals -4 when x is less than 2 and is equal to 9 when x is greater than 2. Which is true for the limit of the f of x for x approaches 2. So x approaches 2, so which is true. So notice that if this is to the left side, which we got a -4. So you got the limit of the f of x as x approaches 2 on the left side, and that gives you -4. And the limit f of x approaches 2 on the right side, positive side, we get a 9. So what can we say? The limit of the f of x exists? No. That's a -4 and that's a 9? No. It does not exist. The limit of the f of x exists? No. So it doesn't exist because they're different. It does not exist. So the answer must be C. The limit of the f of x does not exist because the limit f of x 2 to the right is not equal to the limit of f of x to the left. So C is the correct answer. Again, I made up some multiple choice questions just to have different style questions. And number 2, the h of x equals 4x minus 7 when x is greater than -2. X cubed plus 9 when x is less than -2, which is true for the limit of the h of x as x approaches -2. And again, as x approaches, let's see, as x approaches the limit of the h of x, we're approaching 2. X is approaching 2, and this is the positive side, so we get 4x minus 7. So the limit of h of x is equal to theirs. So if we take the, rub that out and take -4, plug in the 2, we get -8 plus -8 subtract 7 is -15. Sorry, we're approaching -2. Better be careful. There's -2 on the positive side. So it's -2. So that's a +8. So that gives us a 1. And so the limit as we approach the limit of the h of x as x approaches -2 on the positive side, that gives us the limit is x cubed plus 9. So x is -2 cubed plus 9. -8 plus 9 is 1. So we got a 1 there and a 1 there. Okay, so which of these is true? Okay. The limit of the h of x does not exist. It does exist because they're equal. The limit on the right and the limit on the left are the same. So this is false because they're equal to 1. The limit of h of x exists. That's okay. And it's equal to -7. False. The limit of h of x exists, equal to 1 and 1. True. Equal to 9. False. So this must be the correct answer. The limit of h of x exists because they're both equal to 1. Right? It exists and equal to 1. True. So D is the correct answer. And a few more different, again, very similar questions. So number 3, the p of x equals 5x plus 2 if x is less than 1, equal to this trinomial if it's from 1 to 3, and is equal to this binomial if x is greater than 3, which is true. Well, let's look at where the limit, again we got at 1 and 3. So let's look at the limit of the p of x as x approaches 1. So this is 1 on the left. So what does that give me? That gives me 5x plus 2, 5. We're approaching 1 on the left side. So that's 5 plus 2, 7. And the limit of the p of x when it approaches 1 on the positive side. So 1 on the positive side is greater than 1, so it's between 1 and 3. So we have 2x squared minus 4x plus 3 approaching 1. So we put a 1 in. So 1 squared is 1 times 2 is 2. Negative 4 times 1 is negative 4 plus 3. So that's a 1. Okay. So now that's looking at when at negative 1. So the p of x at 1 is 7. So the p of x as x approaches 1 is 7. No, this is at 1. So to the left is 7, to the right is 1. So this is not true. We can't say this because they're not equals. So this is false. So we don't have to look at this. We don't even have to look at the 3. But we got to look at the 3. So the limit of the p of x approaches 3. So we have to look at the 3 now. So the limit of the p of x as x approaches 3 on the positive side. So if you approach 3 on the positive side, that's right here. So that's 4x minus 3. Positive side is greater than 3. So we're approaching 3. So 4 times 3 minus 3, 12 minus 3 is 9. And so what's the limit as you approach the p of x? What's the limit of the p of x as x approaches 3 on the negative side? On the negative side, this is from 1 to 3. So it's coming in here on the negative side. So we have 2x squared minus 4x plus 3. And we have to put 3 in place of x. That's a square. Put 3 in the place of x. That's 3 squared is 9. That's an 18. Negative 4 times 3 is negative 12. Plus 3. So 6 plus 3 is 9. So approaching 3 on the right, 3 on the left, we have a 9. Okay, so that means the limit at negative 1 doesn't exist. The limit at 3 does exist. So the limit of the p of x at 3 is 9. True? And the p of x at 1 doesn't exist. So, without going any further, B is the correct answer. And we have number 4. Let's look at this and see what we have. The d of x is equal to the root of x minus 1 when x is greater than 5. And negative 2x plus 12 when x is between negative 1 and 5. Negative 15x plus 1 when x is less than negative 1. Again, we have at 5 and we have at negative 1. So let's look at the limit of the d of x as we approach, but let's take the 5. X approaches 5 plus, so that gives us the root of x minus 1. We're approaching 5, so 5 minus 1, square root of, that's the square root of 4. Square root of 4 is 2. So let's look at the limit as we approach d of x when x approaches 5 on the negative side. X is approaching 5 on the negative side. That's on the left side. This is on the right side. Greater than 5 is on the right. X is negative 5 is on the left. So that's negative 2x plus 12. So approaching 5, negative 2 times 5 plus 12. Negative 10 plus 12 is 2. So that means the limit as it approaches 5 is 2 and it exists. So the limit as d of x approaches 5 is 2. So the d of x approaches on the positive side is 2. That's okay. Now we have to do at negative 1. So at 5, this is true here at 5, so the d of x as it approaches negative 5 is 2. And that means that the limit of d of x as it approaches 5 is 2. So these are all correct. We have the word all here, so this is true so far. Now we have to do the limit as it approaches negative 1. So the limit as d of x approaches, we're approaching the negative 1. And let's go with the negative 1 on the positive side. Negative 1 on the positive side would be here, because the positive side is on the right. So 5, 4, 3, this is the positive side. So there's negative 2x plus 12. And we're approaching negative 1. Negative 2 times negative 1 plus 12. 2 plus 12 is 14. And so we have to look at the limit as it approaches the d of x as x approaches negative 1 on the left. Approaching negative 1 on the left, this is the left side. Less than is left, so we get a negative 15x plus 1. Negative 15x, x is negative 1. So that's 15 plus 1 is 16. Okay, let's see. The limit, let's see. The limit as the d of x approaches negative 1 on the positive side is true. And approach d of x as x, the limit of d of x as x approaches negative 1. So that means does not exist. That means the limit on the right is not equal to the limit on the left. So that's true. Okay, and the limit as it approaches negative 1. Oh, I got, that's not supposed to be there. That's supposed to be just a negative. Little mistake there. As it approaches negative 1 on the left is 16. That's true. So this is true, this is true, this is true. So the best answer here, which is true, they're all true. You can't say A, B, C. You can say A is true, B is true, C is true, but they're all true. So I just wanted to make up. Again, looking at the limit on the left of 5, look at the limit on the right. If the two limits on the left and the right are equal, then the limit at 5 exists as 2. But here, notice at negative 1 on the right, 14. Approaching negative 1 on the left, 16. They're not equal, so they don't. The limit does not exist at negative 1, because the two left, the left and right is not the left and right are not the same. So again, a few different questions to look at the limits on the left and the right of a number. And if you like my video, click on the like button, click on the subscribe button, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained. Just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.